Welcome to Careless Coder. Today, lesson 3 of Amiga Assembly. Motherfucker! So today we're going to code a raster bar that humps up and down like a rabbit. And trust me, that is the last sexual innuendo that I do this time. Because, well, it was getting a bit much, right? Then again, I may say at a certain point I like colons, but then I mean the double dots, you know? Not. Okay, let's jump in and let's get started. So today we're going to make a copper bar bounce along a sine table. This is the sine table that I created. I have a little tool created that creates these tables and writes them out in this format for you. So it's a long lesson. We're also going to be covering interrupts, so I will be copying some code from certain places that we did last time, like the rotate copper bar, etc. We just copy that because that is lesson 2. If you cannot follow along, then go back to lesson 1 and lesson 2. First, we're going to Ctrl-Shift-P, snippets, create that startup, right. And right, and we put this as exit. Okie dokie. And then we're going to set up, first the copper list. Let's start with the copper list. Copper list, and we move that in A0, and I will copy that copper list. This is a new one that I created for this exercise. I also copy the variables that we may need. Right. And let's move this variable up there. I'm not going to make things beautiful. It's beautiful in GitHub. It's aligned in GitHub. We need to move on because these lessons will get otherwise very long. You should know this by now. Move long A0 into the cop1LC relative to A5. So we set up the copper list. Now we need to enable the DMA to let that run. 8080 DMA con A5. And now we're getting to something new. Oh. Move long. Move word, sorry. Move word. Now we're getting to something new. I'm triggering here, in the copper list, I'm triggering a copper interrupt by moving this value, 8010. 80 basically means enable that shit. It's already there. And 10, that's the 5th bit, 0, 1, 2, 3, 4. Coprocessor. So after this line is done, it will actually trigger the interrupt. And here, this is the end. So we have the copper list triggering an interrupt. And as you could see, if you look at the interrupt request, the copper triggers interrupt 3. But we have also the vertical blank that triggers interrupt 3, the blitter. So when we set up the interrupt handler routine, we need to make sure that we only handle the copper when the copper is triggered. So let us first set up that same value here, 8010, interrupt enable register A5. Then we need to set the VBR. This is just to get the IRQs to work. Base memory 0 in A0, and then we tell that we can find the interrupt handler for IRQ3, where A1 points to in address IRQ handler, and then we can just move the copper bar by branching the subroutine. So we already start moving. Move copper bar before that interrupt happens. It basically draws it, sets it up. Then we have a wait. This is our loop. And what this interrupt handler will do, it will actually increment these two variables. So basically they count the number of frames for the rotate bar and the move bar. And that way we can compare, like we did in the previous lesson, when to actually spin it. So I will rotate the copper bar every second time, rotate bar. If that is equal, then we jump to rotate. If not, rotate, not rotate bar. And otherwise we move on. Let's do a .1 here. We do the same for the compare the move bar, and I want to move it every frame. Gives it a bit more smoother move. If it's equal, then we're going to move to byte. Branch equal, move to jump to byte. And let's do the bit test here. Bit test 6 on the CIAAPRA. Branch not equal, then we go to the wait. Branch not equal byte, we go to wait. And we just keep looping, and otherwise we branch byte to exit. All right, then we have the dot rotate here. Branch subroutine B rotate bars. I'm going to copy this one from the other code base because the rotate bars is the same except for the number of lines. Oh, what is happening here? Rotate bars. And then we need to reset that frame counter. Move B. We put 0 in the rotate bars. Rotate bar, rotate bar, rotate bar. Thank you. And we jump back to dot wait. And we have the move bar. We call that move, right? I like colons in front of it, even though it's not required. We're going to jump to the subroutine, which is only a byte away. Move copper bar. That one we're going to write from scratch. And again, when we trigger that, we need to set the move bar to 0. And we're going to branch back to the wait. I don't need that one then here. Makes it a bit cleaner. All right. Okie dokie. So we called the wrapper rotate bars. That should be beyond this. Oh, rotate bars. So we load equal the copper bar 1. That's the beginning address. As you could see here, that is the beginning address. We put that in A0. And then we jump to the subroutine because that subroutine uses that A0 rotate copper bar to do its business. Branch B. And then we return from this subroutine. So here we call that subroutine. It will set up and actually call the rotate bar. That I'm going to copy because we did that before. The only difference is that these copy 9 bars. So there. Okay. We're currently not moving anything. So move bar, move copper bar, RTS. Let me first see if something is spinning or building correct. Don't want to code too much. IRQ handler undefined. IRQ handler. Oh, we did not set up the IRQ handler. Yeah, I need to do that first. Let's, where will I put it? Doesn't really matter. Let's put it here. IRQ handler. Right, you always return exception. An interrupt is also an exception. Kind of weird, but you always need to save your whole stack frame. D0 to D7, A0 to A7. And sometimes I use the shorthand and sometimes I use the longhand for this. This is the longhand. Well, it doesn't matter. Because here I use that shorthand D0 to A6. Let's use the same thing. D0 to A6. And let's SP plus D0 to A6. Right, so we have a stack frame. And now we need to see which interrupt triggered interrupt 3. And we're going to do that by reading from df plus the internet tenor in A0. So basically it says add interrupt enable register to dff0. And then I can actually read that byte. It's a word actually. It's a word. From A0 into D0. And then we can do a bit test. And that was bit 4 on D0. Branch equal to increment frame count. And otherwise we branch to dot exit. Branch short. Branch short to exit. Dot exit. And before that we do the dot inc. Come on. Inc frame count. Simply going to add one to the move bar and add one to the rotate bar. Rotate bar. And let's be explicit that we only use bytes here. Okay, now see if we have a spinning bar. Did we have any typos? Okay, but it's not spinning. So either the interrupt is not triggered. Oh, something happened. We have a crash. Something is not correct yet. Why not? I save that. I restore that. Move many. Oh, not long. Let's make that explicit. And we're actually here comparing that move. Yeah. That should have worked. Oh, I see what I forgot. I exited, but I do not acknowledge the interrupt. So I need to acknowledge that 10, so that interrupt, that fourth bit, that we actually handled that. And that is in the interrupt request register, also relative to A5. Now I think we should have something spinning. Run without debugging. There we go. Okay, so we have an interrupt, and all we now need to do is make it move. So let's implement that move copper bar, which basically is a matter of taking the location, that location, and just adding and subtracting that offset, because this tells what to wait for, and this is that line. So we're just going to use that. And I want the copper bar to start in the center. So I created that center, that is AE. So basically that's the offset. And let's put it in D3, because now it was somewhere halfway, not properly halfway. Again, we need to load the copper bar offset, copper bar 1. And since we only need to be focused with the first byte, that's easy, because copper bar 1 actually points to this first byte. And this is where that line starts. So not as complex as scrolling them up with the colors and the rotate. Where is my code? I am lost here. Copper bar, let's put this in A1 and let's load the effective address of the sine table in A0. We have them. So first I'm going to move the value in the sine offset into D0. So currently it's set to 0 because we start. So it points to this byte, and that will be added to that offset. And then we will increment the sine offset to 1, and we go through until we hit the end, and then we need to set it back to 0. So let's implement that. So if compare word from end sine minus sine with D0, if that is equal, then we're going to do something. And here you see that's the label end sine and that's the label sine. And I have an application written, I will show you in a moment, in Rust that actually generates these tables accordingly in a visual manner. So that's also kind of cool. Compare that. If it's not equal, then we can get the value from the sine table. And otherwise we will move 0 into D0. And let's do that a byte. And let's move move D0. A sine offset, is that a yeah, that's a byte. Move byte D0 to sine offset. Right, then we reset that, and here we do the get value to get that sine offset value. Move the byte that is in A0 and with the offset D0.W in D2. D2. And we're going to add 1 to the sine offset because we actually read something from it. And now we're going to move all the 9 lines. This copper bar has 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to use that infamous DBF that we used before. And this is the actual move. Let's call it a local one. So we're going to move the byte, going to create a copy of that sine value in D1. And then I need to think, and then we need to add to D3, that is the offset from the center of the screen, this offset, yes. And then we're going to add 1 to D3 to move to the next line. And we're going to move then the value in D1. Move byte, the value in D1 to A1. And then we need to add, I believe it's 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 bytes to get to the next line. Add B. Let's do a long because add 8 to A1. Decrement branch. Dino, dot move. So now we should have a bouncing bar. Build error. Show errors. Oh. compare. Where is it? Ah, yes. That should be this. Fingers crossed. Is it moving? It is moving, but it's a bit spastic, right? Yeah, it's a bit spastic. Why is that? I must have an offset wrong somewhere. Yeah, remember when I moved this sine offset up? Because I wanted it here. Yeah, no, it needs to be in the data RAM. Then it satisfies it. Like I said, famous last words. There we go. So we have a pulsing, nice little raster bar. Now I told you I have a little tool to create these sine functions. Now this sine table is something that I generate with this tool, sine table generator. It's a tool that I wrote in Rust. You can get the code here. I will put the link in the description. Just install a Rust compiler and run cargo build, and be sure to match these dependencies depending on your version, rawhide or Linux, and on Windows and Mac it just builds without it. And basically what it does is, well, generates a sine of course, but you can set the number of points. If you click at save as sine, it will actually generate a sine.s file in the root where you start this. And you can have your amplitude. You can see when it's actually clipping. Yeah, so this is it's a nice convenience tool. It even calculates the number of seconds if you run it every frame. So in this case, if it's 50, of course, it should be 1 second for 50 hertz. So and let's make it a bit more slow and a bit taller. And let's copy this in here. And then we run it. Did I still have some? Yeah, I still had an experiment running. There we go. This is one that has an amplitude of 57 and 255 steps. So you see it's a bit more smooth. And since we update it every other frame, starting at 0, it's a bit slower. But yeah, that's kind of nice. Since this is moving slow, maybe we want to speed up the rotate bar a bit. Let's do that. Oh. So have it rotate a bit faster, have some contrast. Yeah, I like that a lot better. That is a bit trippy, right? So yeah, this is a handy tool. And the irony is I wrote several of them in Pascal, in C, and I always lost them, and I figured let's do it one more time for something that is cross-platform, that just works. Because whenever you do these sine tables, you always use a sine generation. Generally on these slower machines, you don't want to implement a sine or cosine function. So yeah, another little nugget. So there you have it, a moving raster bar along a sine wave. We learned how to create a copper interrupt based on a certain raster line, and you can actually trigger that several times if you like, as long as you just handle that interrupt in time. And we learned how to create a nice sine table that we just use as an offset for that raster bar with a nice little tool that I've created in Rust. The links are in the description, so I hope you learned something, and see you in the next one.